Good afternoon. Welcome to the today's podcast. My name is Matthew O'Keefe. I'm a vice president at Oracle Corporation, working in engineering, and I have with me Ron Mayfield, who's one of our distinguished enterprise architects. Ron has got many years of experience deploying different technologies into the enterprise, and he was with us last month on our previous podcast, talking about decision models that help you make the really good decisions when you're thinking about how to deploy different technologies to meet business needs. So why don't I let Ron is what's known as an enterprise architect at Oracle. So Ron, why don't I let you go ahead and introduce yourself and tell us a little bit about what you do, and then we'll jump into today's discussions around how to build database as a service using your model.
Okay, very good, Matt. Yeah, thanks again for having me. Yeah, my name's Ron Mayfield. I'm a distinguished enterprise architect at Oracle. I've been an Oracle employee for 33 years. I've worked with probably close to 250 customers over that time, assisting them in matching business requirements to Oracle technologies. And as Matt said, as an enterprise architect, I have to be able to look at all levels of an organization to make sure that we are aligning technologies with business requirements. So if I have to, in a nutshell, if I had to say, what do I do? That's it. Aligning technologies with business requirements to make sure that a customer gets the most value out of their investments.
And I think you've had in your long career, you've had a lot of different positions, right? And can you maybe describe some of those positions, and how does that affect the viewpoint you have when you've been able to do a lot of different roles in the enterprise before you kind of get to where you're at?
Yeah, great question, Matt. So I got an MBA, concentration in MIS, went to work for one of the consulting firms, and started out programming. Way back when, even on mainframes, programming. So the first 13 years of my career, I was in consulting, where I was with customers, hands-on, doing design, analysis, and implementations. And that gave me a very good perspective of full lifecycle implementations. So after those 13 years, I was a project manager, lead architect. So I would start a project with customer, business user, what is it that you need? What are we going to accomplish? And then take those requirements all the way through to implementation and run and maintain. But again, that's very important for an enterprise architect, I believe, to have full lifecycle implementation experience, because when you're in the conceptual or logical model, if you know how a decision is going to affect how a technology is going to be implemented later on in the life cycle, then you can make much better decisions.
Right.
I think we talked about this before. I use the analogy of a grandmaster chess player. Grandmaster chess players 10 to 12 moves ahead of where they are on the board in their heads. The enterprise architect needs to do the same thing. And we may be working on a logical design, but the enterprise architect with full lifecycle experience should be thinking about, here's how physically we can implement this. This is what it's going to take to build this, and this is what it's going to take to run and maintain.
Yes, and I mean the other advantage, usually multiple roles, means you've had quite a few years of experience. So you've seen projects that work, projects that fail, projects that do okay. So you can kind of see end to end how a project's done, and then you build up, kind of accumulate experience based on that. Well, is that true?
Yes. But fortunately or unfortunately, I've been very blessed in that I've never been on a project that failed.
Really?
I've always had very good mentors, and we were able to really get things done and be successful. A lot of on-time, on-budget implementations.
So that's kind of amazing, because there's projects, really massive failures are not uncommon. In fact, it comes up quite often in the podcast, specifically what kind of bad decision-making leads, or lack of governance or processes or whatnot. What leads to really massive multi-$100 million or billion-dollar failures?
Well, I think it goes back to, as a good enterprise architect, if you're making good decisions early on in the life cycle, then you have a much greater chance of being successful. But I've seen studies that say it takes $1 to fix an issue when you're in the conceptual logical model. It takes 100 times that to fix it if you're in the physical model, or even more if you're in the build.
Yeah, and that's a classic software engineering principle, which is, to your point, the sooner you get the stuff that you get upstream incorrect has these these big multipliers in costs. It's nonlinear in terms of the increase in cost to deal with it.
Yeah.
And actually, that's where the vast majority of these complete train wrecks happen, is that the upfront decision making, there wasn't requirements weren't properly gathered, and so they end up changing a lot, or the architecture wasn't designed quite right. And but very often it's just too many changes in the early part of the process, and not being able to really cost constrain that as you go later. So
yeah, we could probably do a whole podcast on why implementations fail.
Yeah,
because having talked to people who have been on those that fail, all those things that you listed are possible variables that would cause failure. But
Yeah.
one thing I've seen too is organizational structure and the lack of communication.
Mhm.
When you were building these very large, especially the really big complex systems where you have a large system, but you've got hundreds sometimes of interfaces, and that all has to be coordinated in time and good project management, those sometimes are also variables that cause failure. If those are not done correctly, you can get yourself behind your dates and way up on your budgets pretty quickly, and then you get shut down.
Yep, absolutely. So we're not going to cover that this podcast, but let's dive into one of the things we talked about last podcast was this, what you call the ICAM model.
Mhm.
Helps you basically classify data, and then you can leverage that to figure out which platforms and systems are best suited for it. So could you just kind of describe for us just quickly what ICAM is again?
So ICAM stands for Information Characteristics Architecture Method. And you want me to start sharing?
Yeah, if you want to go ahead, and then I'll let your screen.
And I'll bring up the list. Okay. Start off with a nice sunset picture.
That's right. Nice, peaceful sunset, which is coming soon.
So here is, at a high level, ICAM. Again, in the last podcast, we went into detail on this. But these are the 7 characteristics that myself and several other people at Oracle, over a couple of years, evaluated to find out what we thought were the most important characteristics of information to determine what the best fit information management technology is going to be for that information. So if you'll go look at the previous podcast, we went through this in detail. There are 17 variables, and the first 8 are the variables or characteristics that the owners of the data, the end users, should measure. They're the ones that should determine, like, what is the time value of the information? What are security requirements, regulatory? What is availability? Owners of the data should determine that. Then the last 9, those are to be measured by the information architect. And these will get you to all sorts of characteristics of the information, get you all the way down into sizing, even once you start measuring these.
So you have the people that own it, and then the people that need to figure out how to present it and manage it and leverage it.
Mm-hmm. And then we, like in the previous podcast, we did a 1 to 10 scale on each one of these and set high and low values, and then ran through some use cases and then put the results on radar charts so that you could very easily see patterns.
Mm-hmm.
So it's pretty easy to pick up what's a relational database pattern, what's a big data pattern, what's a NoSQL pattern. They're very, very different when you start measuring these characteristics. So it's a good way to go through, and instead of doing one of those, we need about that much, and this NoSQL product is a hot new thing out there, and I want that on my resume. This gives you a quantitative way of making good decisions on what's the best fit information management technology for this type of data, this type of information.
Yeah, and one of the reasons I love it is that some of these biases that I've talked about in previous podcasts around reasons people make a decision that really isn't completely based on, I don't know if you want to call it facts and logic, but rather sort of hidden biases that make it really difficult to make an optimal decision for the best design. So what I love about it is it sort of abstracts out characteristics of the information, then what you want to do with them, and then abstracts what the platforms, it's pretty, and I don't think, when you laid out, like, here's what a classic NoSQL database might do, this is what a classic relational database might do, that's pretty objective. I mean, people can look at that and say, yeah, that's really what most of them are like. So
Yeah,
it's very helpful.
I've given this to several of my customers, and they love it, especially the DBA teams.
Yeah.
Because there's this tendency, not all developers, but a lot of developers will go after the latest shiny penny, and then they'll go build something, and then they'll throw it over the fence to the DBA team to maintain it.
Yeah.
And the DBAs needed a way to be able to push back and say, here are the actual requirements. Here's what you need. You don't need the shiny penny. Here's really what you need to meet the business requirements. So it's a quantitative way of being able to make decisions.
Yeah, it's interesting because you brought up that topic. I was dealing with an Oracle customer. I can't name them, but anyway, an Oracle customer that really had that same issue, which is there was a proliferation of databases that the developers wanted to use, and the infrastructure team really could not support that many different databases, and they couldn't quite figure out a model to have just the app developers do it in a way that was really scalable and reliable and available, and all the other sort of critical characteristics. So I think this model, frankly, would have been very useful in that case as well. But you've used it, haven't you? You've used it with several large enterprises, if I correct?
Correct. Mm-hmm.
Yeah. And I think one of the areas you and I talked a bit about was database as a service. So maybe you could explain just first off, Oracle is known, for being the one of the kind of the major relational database companies. What's it doing in the cloud with respect to the database? And then from there, maybe seg into how do we use this? How do we think about database as a service, leveraging some of the models you've developed?
Right. Okay, so being an information architect and very much database oriented in my career, I take a somewhat not always politically correct view of the cloud. The cloud is just another deployment option. Mm-hmm. It should be evaluated along with other deployment options. So public, private, hybrid, you can do any of those environments, database as a service. So cloud, because we're automating, the cloud vendor has automated a lot of the IT processes. A lot of times it's much easier to do in the cloud if you're just starting off with a database as a service. Well, we've had customers who've been using Oracle for 20, 25 years, and they're very good at doing database as a service on-premise. They're very good at it. Mm-hmm. And so, I'm a database guy. It runs in the cloud, it runs on-premise. It doesn't matter to me as long as my information is available.
Mm-hmm. Very good. So how does one think about, if you're going to go in that direction? So database as a service is something that you're providing developers and users quite often as a self-service. That really puts a lot of demands on how you're really going to go about delivering a database relative to the classic way of laying out a server and installing a database and on and on.
The answer is a qualified yes. So if you're provisioning small dev test databases, then yes, you want self-service. Mm-hmm. If you're provisioning a very large, very complex, mission-critical application, you need highly trained professionals to make sure that is done correctly. So that's what I mean by qualified yes. Mm-hmm. Now, I was a developer when I was in consulting, did a lot of hands-on development. I know as a developer, I'm free when I have no constraints. If you can give me my own environment and just turn me loose and let me go and try out all sorts of whatever I want to try out, all new features and this capability, this design, that design, then I become much more agile. Mm-hmm. But as you move toward from dev test into your system test, into your quality assurance test, into production, that's when governance processes need to be put in place. So it's a yes, but it's a qualified yes. There are times when you want self-service provisioning, a lot of benefit. There's a lot of times you shouldn't do it, it's going to hurt.
That's interesting because that really fits into the model though, right? Because, several the characteristics of these ICAM characteristics play directly into which one is one of the other.
So we have a model we call Journey to Database as a Service, and it has 20 steps in it, or 20 processes or things you should consider. ICAM is one of those. So ICAM is one of the bigger pieces of the puzzle in database as a service. So if you like, we'll go ahead and jump into database as a service.
Sounds good. I'll get you back in control of the screen.
All right, so let me get this started. Okay. One of the things that enterprise architects should be able to do is to take something complex and be able to analyze it, and then to convey those complex concepts in a way that is easily consumable to management, as an example. So the first thing we did looking at Journey to Database as a Service is we put this structure around it. We looked at what governance processes need to be there, what operational processes, and then what are the enabling technologies. And then we put it on a roadmap across time, which gives you a phase 1, a phase 2, and a phase 3. So that's the overall structure. Then we're going to add the processes. Then we're going to talk also about the relationship between the processes. So between the structure, the processes, and the relationships, what you get is something that's very transformational. So let's jump into it. So the very first thing that you need to do is assess what you have. So you assess currently deployed information management technologies. Do you have 5? Do you have 10? We had one customer that had 25 different information management technologies. Assess what you have. Then you also need to assess your DB compute and storage capacity. How much do you have? Are you strapped for storage and memory, or do you have some excess? Because that's going to play into what happens later on. Okay, so first step is you really need to assess what you have. And I'm really surprised that a lot of my customers, they don't know what they have. They do not have a good configuration management database.
Yeah. So
that's one of the first things is the discipline of having a good configuration management database. Then here's ICAM. You develop and implement an information management technology selection governance process. That's what ICAM is about. Looking at the characteristics of information, putting in place that governance of, is this the best fit information management technology? Now, once you have something like ICAM in place, then you can go to step 4, which is rationalize existing information management technology. If we have 25, do we really need 25? Based on the business requirements and the measurements we do in ICAM, do you really need 25? And this will allow your customers to start a consolidation and simplification process. Next comes, you need to get an understanding of how mature your database operations processes are. So document currently how you do things. So you need a good understanding of the capabilities of the IT organization. Then, and this is the big one, this is a really big one, then you develop your DB technical services catalog with sizing options. So at Oracle, we have something called maximum availability architecture, which gives you 4 levels of an architecture that have different capabilities. So let me bring up an example. I have a very, very detailed technical services catalog that we created for one of our customers.
Okay.
So let me bring this up very quickly. And can you see that okay?
Yes.
All right, so here's the structure. So in column B, we have the 4 levels: platinum, gold, silver, and bronze. And in each one of those, we have business requirements for availability, recovery point objective, RPO, recovery time objective, RTO, RPO and RTO. Then to meet those requirements, we make a list of, here's what you need to have. You've got to have these capabilities. And of course, this is very much Oracle database focused. These are the required capabilities. And then we put some optional ones too, that depending on what the customer is doing and what their capabilities are, what they can do, they might want to add these like addition-based redefinition in the Oracle database. Phenomenal feature, very few people know how to use it. Okay, so for each level, what's required, what's optional to meet the business requirements. And we also list over here are database options. So do you need partitioning, like you're doing a big warehouse? Do you need machine learning? Do you need in-memory analytics, sharding, blockchain? Based on the business requirements, what options do you need? And then again, based on, and one of the measurements in ICAM is security, what security options do you need? And the last one is application developer services. These are services that can be provided in the database for the developers. Okay. And then we do sizing. And some customers do 4, 5, or 6 sizings. I did 5 in this one. And these are just rough numbers. It's up to the customer, again, by looking at what they have, then they can get a range of what is it they're using, what capabilities are they using across. This is how you size any system: cores, memory, I/O throughput, and storage size. It's a round number. Okay, so now you get this grid, and what you can do, and here's an example, is say, like, for this particular application, here are the requirements. Well, we have gold level, we need availability of 99.9, and an RPO of less than 10 minutes is okay, and an RTO of less than 30 minutes is okay. So we can be down for 30 minutes, and we lose 10 minutes a day. But here are the details. Performance, there's 300, on average, 375 concurrent users and processes. We have a requirement of less than 200 milliseconds for latency. Then we need these database options: spatial graph, machine learning, XML, JSON, text. And in security, we need, again, what we're doing is we're picking and choosing what's needed from this list over here on the right. So security, transparent data encryption, network encryption, data redaction, database vault. For application developers, we need ORDS, which is Oracle REST Data Services, SQL Developer, and Application Express Apex. So now we have a really good idea of what this application needs by mapping those requirements to this very detailed technical database technical services catalog. So this, again, adds a lot of structure to the process. So this is number 6, develop that technical services catalog with the sizing options. That again goes back to consolidation, simplification. Instead of having every system architected separately to meet specific business requirements, you start with these 4 levels of the architectures and then drill down on what's needed by that application.
I see.
And by doing that, you get more standardization, a lot more standardization. And it helps a lot too in long-term knowledge of that application and the system supporting it. If you get some new people in and they say, what the heck is this system? What is this? You can say, this is a gold large system. And you go back to the spreadsheet and get information about this is what's been deployed. So it helps with the long-term knowledge of the systems. Okay, so that's the big one. That's a real big one. I push building technical services catalogs to my customers a lot.
Cool.
Okay. Next one is 7 and 8. So once you have your technical services catalog, you can then begin to standardize your processes for capacity, availability, continuity, and security management. Because you have all of those in your technical services catalog now. So you can start to, like I said, standardize those processes. I've had a lot of customers who are not good at, as an example, at capacity planning. They basically do does it fit? No, let's stick it there. Instead of being more professional in that process of making sure it goes to the right place. And actually, this is such a big one. Let me pull this up. I worked with several customers in identifying what are those variables they need to consider when they're consolidating. So the goal is to consolidate as much as possible. So the default is stick it all together. But there are reasons why you can't. And you have to isolate and separate. The more you isolate and separate, the more platforms you have, the more you have. It makes things more complicated. But here are some of the reasons that you can't consolidate. You need to look at the workload profile over time. You don't want to put systems that all peak at the same time on the same system, because then you're going to overload the system during those peak times. You don't want to put systems that have different availability, RPO, and RTO requirements. You want them to be on the same level of the service catalog. You want all your golds together. You want all your silvers together. Some systems, and again, this is one of the things we measure in ICAM, security and regulatory reporting requirements. Sometimes, and I've worked with state and local and federal governments before, sometimes they're required, customers are required to segregate systems that have, by law, security and regulatory reporting requirements. So you need to be aware of that. Application maintenance windows. If you got to take the system down to do the maintenance, you want all those systems to be maintained at the same time. Application DB patching and upgrade cycles. A lot of customers get in trouble with this one. They don't work with their end users to make sure they know what those patching upgrade cycles are going to be. And they put systems, applications, database on the same system, and then one application can't be upgraded when it needs to be because the other ones are using the same executables. So they have to be all patched or upgraded at the same time. Number 6 is internal costing and chargeback processes. I've seen customers say, this is my system, it's mission critical, I'm paying for it, I don't want any other systems on this. So it kills the consolidation. And that's kind of like number 7. There's sometimes line of business and user cultural restrictions. This is the way we've always done it. We put these types of systems here, we're going to keep doing it. So that's my speech on consolidation. You want to consolidate as much as possible, but you need to be aware of why you can't consolidate. Okay, then, let me go back.
I really like your consolidation. That really lays out some very critical, things you need to think about, because often it's just people think blindly. Well, I have 1,000 databases, and I'm going to put them all on 10 Exadatas, and et cetera, et cetera. But to your point, it's a lot. It's definitely more. You need to be more thoughtful.
The record that I've seen is one customer put 57 databases on one node of an Exadata.
Okay.
And they had problems doing patching and upgrading.
Yeah.
And it actually wasn't the customers, they're outsourcing. Okay, so number 8, design processes for optimizing DB consolidation. That's a big one. Next is, now let's go look at what kind of enabling technologies that you have. So assess your current DB management and monitoring tools. And I want to differentiate between management and monitoring. There's a lot of monitoring tools, but you want to make sure that you have tools that can help you automate your management, actually making configuration changes. Like our enterprise manager is so sophisticated that it will monitor a database. If the database goes down, enterprise manager will be able to grab that alert and then automatically, without DBA intervention, restart the database. So make sure you understand what are your database management and monitoring tools.
Yeah. And
then evaluate. Number 10 is evaluate the automation technologies that you need for provisioning, upgrading, patching, cloning, and chargeback. So take an inventory of what do you have that have those capabilities. Okay, then we get to 11. So this comes from, as you see, 6, the technical service catalog, and 3, which is ICAM. So 11 is, now that you've chosen the catalog and what the best information management technologies are, then you need to design and implement a process to choose the best fit platform for an information management technology based on the business requirements and the technical services catalog. So if it's a bronze system, RPO, RTO, not that big, availability not that important, well, you can go stick it on some commodity, put it on a VM farm or in Kubernetes. No big deal. If it's a mission critical system where you need multiple 4-node rack cluster and Golden Gate to do replication, that's a whole different platform, a whole different set of requirements.
Yeah. Yes, it is.
Okay. Now we have our best fit information technology, our best fit platform. Then now we can gather information from catalog, from optimization processes, for standard processes, for capacity, availability, continuity, and security. Now you can design provisioning, upgrade, patching, cloning processes, again, for each level of the database technical services catalog. Because the way you clone, like we talked about before, self-service cloning for dev test of bronze databases, completely go automated. But again, if it's a gold or a platinum mission critical system, that's a different set of processes.
Absolutely.
Okay, now that you've designed all those processes, you have the best fit information management technology, the best fit platform. Now you need to decide what is the best fit platform deployment option. So design and implement a process to choose the best fit platform deployment option. Does this need to stay on premise? Can it go to a cloud? Can it be in a hybrid cloud? Can it be in multi-clouds? Next is, where's the best place to put this application? The best place to put the database, the best place to put the platform. So those three, number 3, number 11, and number 13 drive a lot of decisions.
Mm-hmm.
Okay, now we're ready to start talking about, so what are those enabling technologies that will get us to database as a service? So 14 is design and implement standard DB builds, gold images, for each level of the database technical services catalog. That goes back to, you've got the 4 levels, and you've got 5 options for sizing. So you have a grid map of 20 boxes, and you can decide, how am I going to clone databases? So, and again, in the dev test environments, it's very easy to set up gold images for developers where they can just deploy it, and now they have the database and they can go play it, whatever they want. 15 is implement the database as service automation technologies where applicable. Again, if you've got a mission critical database, that's not something you're going to automate the complete implementation.
Right.
I don't think our industry is there yet. We're getting there in our cloud, but to do a very complex platinum multi-node rack cluster using Golden Gate to replicate, maybe using recovery appliance to do local backups, a lot of moving parts.
Right. Although that's kind of where Oracle engineering is headed, is to try to automate even the most, what's been considered like the highest level mission critical features, make them essentially automatically deployable.
And we have to do that because our cloud is supporting mission critical applications. We have the largest portfolio of SaaS applications. So we have some very, very large companies who are running Fusion Cloud for their ERP, and those are mission critical applications. Mm-hmm. So yeah, we're being forced by our customers to be able to automate pretty much any deployment.
Yeah.
Okay. Then we get to, now you can deploy DB on the best fit platform with the best fit platform deployment option. You're now ready to make that decision. And when you can, you automate it. When it's not good to automate it, you have some manual processes. Okay, you're almost done. Next is, now that we know what we can automate, let's integrate the database as a service automation with an app dev CI/CD pipeline. And this is what I work with my customers on, because a lot of the CI/CD pipeline people don't realize that you can put into that cloning of databases or grabbing a backup of a database and creating that database. We can automate that completely. It's fairly easy to do in our environment.
Sure.
Okay, then we get to, this is one that some customers do, some don't. They do, but we'll talk about that later. So design new DB technology rationalization and end-of-life processes. So a new technology comes out. Instead of doing the shiny penny, we need to go try this out, have a process in place where you do things like ICAM and evaluate that new technology to see if it fits your business. And then as technologies get older, you have to have a process for doing end of life. Mm-hmm. How do you retire older technologies? Almost there. Then finally, you can design, number 19, design your database as a service chargeback processes. And number 20, implement those chargeback processes. Mm-hmm. So chargeback is tough to do. And I would say until you get all these other pieces of the puzzle in place, you're probably not going to be very good at chargeback. Mm-hmm. But once you get all these processes and define the relationships between the processes, you get those in place, get the automation in place too, then chargeback should be pretty straightforward. Mm-hmm. So there you go, 20 steps to journey the database as a service.
Yeah, very nice. So can you talk about experiences in the field you've had with customers using maybe some or all of this? And you of course you can keep them anonymous, so we don't let any particular company's secrets out. But how has this been? Can maybe give us a sense of like before and after, what had been done before, and then how this might have impacted what they did after.
Okay, this is the interesting part. All of my customers do almost all of this. They may not do number 18 or 19 or 20.
Okay.
But they do the first 17.
Okay.
They have to be able to run their business. Mm-hmm. So it's not a matter of if they're doing it, it's if it's a standard process, if it's controlled governance, Instead of doing things by the seat of their pants, they're making good decisions. So this is really about working with customers, and I'm the least dogmatic person you'll ever meet. I'm very pragmatic, but coming up with these standard processes, coming up with your technical services catalog, putting some structure on the decision processes so that you do make good decisions. It's putting discipline into the whole process.
Mm-hmm. So, but these are typically, you work with the largest Oracle customers, correct?
Yes, I work with our most strategic Fortune 100, 200 customers.
Yeah, I mean, you're basically our top enterprise architect. What about like the companies that don't have as much scale and probably organizational complexity? Are you starting? I mean, there's every reason that this process is still useful. Say it's at smaller, maybe not the smallest companies, of course, or department level, so the equivalent of like a department level, a department in a very large organization that's essentially a startup. But how is this playing out in, say, other companies, maybe born in the cloud type companies, companies that are trying to leverage many different types of data? Are you starting to see maybe portions of this? Are people starting to think in this better, this more systematic way?
Yes, I believe so. As our industry matures, people are getting better and better at these processes.
Mm-hmm.
And if you're talking to a smaller organization where they have less people, then those people have to wear more hats. In a larger organization, you're going to get more specialization, as an example. So that the scale of the IT organization will give you some benefits in that people can specialize and get very, very good at certain areas.
Sure. Yeah.
Whereas
there's also, I think, with large organizations, the risk, because they're typically supporting much larger revenue streams, then that's probably supporting customers in more of a mission critical way. There's just a lot more at stake. And so they make the investments in this kind of framework to really make sure you've covered all the bases is really the best way to go.
Yeah, I worked with one customer, and this kind of blew me away. One of their applications generated 51% of their revenue.
Okay. Wow.
Yeah, exactly. Wow. That is the system we paid a lot of attention to.
Okay.
To make sure the governance and the operation processes were in place and known and followed.
Okay.
It's too risky to do something by the seat of your pants and maybe bring that system down.
Well, the other thing I like about it is wouldn't it kind of force a certain amount of balance between the different decision makers in the you've talked about information architects, infrastructure architects, application architects, and then the bigger thinkers, the enterprise architects. Doesn't this process kind of force a balance between them? Because one or the other can't necessarily just say, well, I want to use this particular programming language, or I want to use this particular kind of, storage server, or this particular database. It really does sort of put it out into more objective, formal process, so that those kind of imbalances don't disrupt things. Is that, or am I being too optimistic there?
Oh, no, you're exactly right. So here's what we see in some organizations. They've decided to specialize within IT. So you have a network team, you have a storage team, you have an OS team, the hardware. You've got all these different teams. So somebody, and this is the analysis we do with our customers, somebody will say, I need a new database. So if somebody creates a ticket, then that ticket goes to the database team, and they do something. They fill out a piece of paper. Then that ticket goes next to the OS team. Then it goes to the hardware team. Then it goes to the network team or storage team. Then it usually goes to the network team. And it'll go through 6 or 7 or 8 different teams. And what happens is that ticket gets into a queue, because each one of these teams has their own queue.
Oh.
Of course, everything in the queue is priority 1, and it all have to be done right now. So what happens is that ticket may take weeks or even months to be completed before the DBA can finally have an environment where they can say, create database. So implementing processes like this has a tendency, if done properly, to bring together the team, the different groups, into teams that work on specific things.
Mhm.
Like number 7, standardized processes on DB capacity, availability, continuity, and security management. Okay, that's one set of processes. You need to bring together people from multiple teams to figure all that out. So instead of it being a ticket that goes into all these different queues and 2 months later you have a database, it allows people to focus, get things done much quicker. So
Yeah, I mean,
you have a team that does database capacity, planning, availability, continuity, and security management. There is a team, a cross-discipline team that does that.
mm-hmm. And what about postmortems? Do you ever see companies, go through a design process and a deployment process, leveraging, this very cool model? Did they ever kind of review how it went, where they could improve? Is that something you'd suggest is a good idea?
Yeah, most of the time we see that when people have an outage and they're doing root cause analysis.
Yeah.
And that's actually very revealing too. If you do have an outage of a major system, if your IT is not organized in teams, where they are cross-functional teams, cross-disciplinary teams, if you will, that you've got the network team, the storage team, this team. What happens is you have an outage, a lot of finger pointing happens.
Yeah.
Which increases your outage time.
Yeah.
So we try and break those down too, to build those cross-functional discipline teams to solve a problem. But what you're talking about, this process, this falls under the concept of continuous process improvement.
Okay.
So it's not a set, if it's done right, it's not we're doing a project to increase or decrease the time to provision a database. That's not a project where you do a post-mortem afterward. It's a continuous process improvement.
Okay. Yeah.
So you're monitoring each one of these processes, the cross-disciplinary teams, and you're measuring how quickly they can get tasks accomplished.
Yeah, very cool. That's very cool. Yeah, I think this comes to mind partly because when you look at like big project failures or just major failures in a technology, there's a couple of biases that tend to play a role. And one of them is the tendency to start to classify what should really be bugs or errors into sort of a acceptable, but maybe a little bit degraded mode. And then not to really dig deep into the root cause of, is that degraded mode really, what's causing it and what could be the consequence of that? And that's also tied to another bias called an outcome. There's sort of an outcome, optimistic outcome bias, which is if you have a system and it continues to work, it could have a fatal flaw, but it works fine the first 10 times, the first 20 times. But there's clearly, you start to think because it worked the last 10 times that the probability it's going to work the next time is really high. But in fact, this sort of these potentially hidden things can start to accumulate. And, that's actually what, that's one of the things that happened to the shuttle when the problems with the shuttle catastrophes where they started ignoring things falling, ice that had accumulated on the engine.
You're getting into an area that's near and dear to my heart. My dad was an aerospace engineer at NASA who worked on Apollo, Skylab, shuttle, and space station.
Oh man, is that right?
And
Did he ever work on these kinds of, what part of it did he work on?
He was in mission planning design. He worked with onboard consumables, environmental systems, gas and electric systems.
Oh, wow.
So if you want to have that discussion, what happened to Challenger, I have a lot of details. But that's a whole another discussion. But it kind of does almost relate to what I see in some IT organizations. So when I go in and I start working with one of my customers, one of the first things I try to assess is this IT organization constantly in react mode, or are they more proactive?
Mm-hmm.
So this is another characteristic of those. We have a storage team, we have a network team, we have an OS team, and that network team, that storage team does everything storage. That's all they do is just storage, which means if there's an outage, they have to do root cause analysis. If there's provisioning, they have to do that. If there's patching, they have to do that. And what happens is, because these cross teams, functional teams, discipline teams aren't working together, then there's not communication. There's a lot of miscommunication, which causes configuration problems, which makes the system more fragile, which means people are now doing a lot of bug fixing and root cause analysis and outage triage. So they're in constant react mode. And because they're just fixing problems, they don't have time to be proactive.
Right.
Because when you're proactive and you do something like what's on the screen, you have those cross-functional teams who identify problems, going back to that enterprise architect mentality, make a good decision now so that you don't have problems later on.
Yeah.
You're able to do that, then the whole IT organization becomes more and more proactive.
Yeah.
And outages and downtimes and bugs, we've seen they go down, way down.
Yeah, and it's back to why one of the reasons I call this, I call the podcast, it's about end-to-end innovation, because obviously there's nothing wrong with specialists. You need specialists that understand deeply the whole, a particular part of the stack. But too often what happens is you just don't have enough of enterprise architect level folks who've kind of played in almost every sandbox and has enough experience to not only understand what's going on in each sandbox, but also how those things interact across them. Because to your point, that's where a lot of these issues came up. Okay,
so a lot of what I'm discussing is associated with a thought. What do I call it? A thought project I've been working on for quite a while now, which is how do you design an IT organization how do you not design an IT organization for change?
Mm-hmm.
And you get into different management techniques. Specifically, there's something called scientific management and another management technique called systems management.
Mm-hmm.
So scientific management was introduced by Frederick Taylor about 1905, 1910. And it was a management technique that brought about the Industrial Revolution, which is take a process which is somewhat complicated, break it down into its smallest parts, and then optimize each part. Works great for assembly lines. But if you try and do something that's not complicated but complex, much less very, very complex, where you have, instead of one-to-many hierarchical relationships, you have a lot of many-to-many relationships between the different teams, that scientific management completely breaks down.
Okay.
What I described before was you have it's just like assembly line. That's what people try and build. You have a storage team, you have a network team, you have an OS team, you have a DBA team. All right, so you decompose everything into its lowest part and try and optimize it. Well, that doesn't work because look at what's on the screen. What we showed before, database as a service. There's no hierarchy here.
Right.
There's a lot of many-to-many relationships between these processes. So this is not complicated. This is more complex, especially when you get into the details. It's pretty dang complex.
Is that ties into the you recently wrote a blog post on sort of different ways of thinking. So deductive thinking is more the Frederick Taylor, breaking things into clean boxes. Abductive is this complexity many to many. And then there was a third that was.
So there's deductive, abductive, and inductive.
Yeah.
So deductive is the variables. You can do if then else type logic. Deductive, inductive is you don't have all the variables. So as an example, we talked about sizing. A lot of times when we're doing sizing, we have to design the system, but we don't have all the variables. We may have number of concurrent users and storage size. So we can kind of figure out memory and maybe CPU, but IO throughput, we don't have any idea.
Yeah.
So inductive reasoning is coming to a conclusion based on the variables that you have. And then abductive reasoning is even worse. This is where it gets really fuzzy.
Yeah.
You may not have very many known variables at all, but through your experience, you know what a good solution is going to be.
Oh,
That's different than dialectical. Those are logical thinking types. Dialectical thinking, dialectical diving to, is thinking of not here is a problem, this is if then else how to solve it. It's let's take a step back and let's look at it from the problem from one perspective. Let's look at it from another perspective, or even a third perspective, and get the different lenses on that problem, and then come up with an optimal solution. Making sure you weigh those trade-offs between the different views of that problem. Those are good thinking skills for when you're addressing a complex problem like database as a service.
Mhm.
But to implement something like this, it's complicated. Instead of doing scientific management, hierarchical, break it down to its smallest parts and optimize them, you use what's called systems management. And systems management is what George Mueller used at NASA for the Apollo program. He was one of the directors for the Apollo program. So when Kennedy said, we're going to go to the moon within the end of the decade, everybody went, that's crazy. There's no way we can build a rocket of that capability to get us to the moon and back, which means they had to build and design the Saturn V. They had to design the command module, the service module, and the lunar module, and they all had to work together. Nothing as complicated, I believe, had ever been tried before. And they were able to pull it off because of system management, which is you have teams of very specialists. Like at NASA, they had all these engineering. They had a lot more PhDs in engineering and physics than you could throw sticks at. My dad was right in the middle of all that. And I got to meet a lot of those guys. They were really, really smart guys. But what they needed, though, were those teams to be coordinated. They were given tasks, and then they need to be coordinated. And a lot of times it needed to be cross-discipline. For the stages of the rocket all to work together, you had to have cross-discipline. So instead of a hierarchical, it's more like a spoke and hub. So your specialist teams are around the wheel, but you have one group, your enterprise architects, your program management people, who are the hubs that control the processes and communication between the different groups, so that you don't have those, like we talked about before, those problems of this interface doesn't work with this technology, that doesn't work with this hardware, that doesn't fit. And then you start getting a system that's fragile. So we can have a whole session on hierarchical, scientific management versus systems management, because the scientific management has been really in the forefront of managers' minds for the last 100 years or more. And systems management is really not used that much because it's for very complex environments, and not a lot of people know about it and its benefits. But
Well, it's
our IT
funny.
environments are getting so complex, we really need systems management to be successful, I believe.
Yeah, and I actually agree with that. I think, and actually, there's some work on like how power, actually operates within companies, and what you see is because the hierarchical is kind of typically how we're all organized, yet it often can't get the job done. There's all these informal, sort of like what you said, which is hubs and spokes that sort of form on the fly, and then may last for periods of time. So there's definitely that's happening in some cases under the radar, but I couldn't agree with you more. I think it's these, what did you call it? So it's hub and spoke, and what's the name of the overall type of sort of
management?
Systems management. Is there a good reference for that? Who's kind of like considered the? Is it like you read history of the Apollo program, or?
That's exactly right. There's a book. I'm not going to remember the name of it, but it's The Secrets of Apollo.
Okay.
And it's system management.
It's literally that's the title.
Yeah, The Secrets of Apollo. And
very cool.
I don't remember who the author is off the top of my head, but it starts with World War II and building aircraft, Air Force focus, because NASA came out of Air Force. How they designed aircraft, which were complicated, but then how they had to transform from building aircraft to building missiles, to building intercontinental ballistic missiles, all the way to building the Apollo program. And how the organizations transformed over time to meet the requirements and get to the moon by the end of the decade. There's another book by General Stanley McChrystal called Team of Teams.
Okay.
And he does a very good job of explaining the differences between scientific management and systems management. So the Team of Teams book is I would say it's a good primer.
Okay.
And it's a good, easy read, but there's a lot of great information in it. The Secrets of Apollo, that's a much tougher read. It gets into a lot of detail. But if you're into military history, Team of Teams is great because General McChrystal was the head of the Joint Chiefs of Staff in charge of eradicating Al Qaeda in Iraq.
I see. Sure. Yeah.
And so he had all these specialist teams, these the SEALs, the Rangers, MARSOC, and he had to try to get all these teams to work together, team of teams, to eradicate Al Qaeda, which was a group of cells. So hierarchy military, not very agile. Al Qaeda, a group of cells, very agile. And so he had to transform the whole organization to become more agile than Al Qaeda. And he was successful.
That's very interesting. Yeah, I mean, traditionally, the military is, extremely. You start at the division level, and then there's battalions regiments, battalions, and then companies, and on and on. So it's literally that. But again, over time, the military adapts. Well, Apollo also has a military background because actually a lot of the rocket scientists we brought over from Germany. So they've been doing the research for the. Yeah,
that is exactly right. And there were a lot of military people. So my dad worked with a lot of Air Force people as an example.
Very cool. Well, hey, we've run over. We're about to come up on our.
We always we get off on all these tangents and discussions.
Yeah, that's right. No, that's all good. Yeah, no, but it all fits within this framework of how do we make the best decisions. What I'll do is I'll take those references you mentioned. I'll make sure I get the right ones, and then when I create the timeline on the recording, which if you're watching it right now, you're watching a recording, very likely. We'll have those references down in the below the YouTube display. So with that, I want to thank you, Ron. Really appreciate your again all your insights and experience. So relevant to what we want to explore here, and hopefully it's useful to the viewers. So thanks again, and thanks everyone for attending. All right, take care. Okay, end broadcast. There we go.